Welcome everyone to another lecture about complex numbers. In this video, we'll learn how to add or subtract two complex numbers. This is actually straightforward. The general rule when adding or subtracting two complex numbers is to have both of them in their rectangular forms. By doing so, the addition or subtraction operation becomes just a matter of applying it once for real parts and once for imaginary parts. As a symbolic example, if we wish to add z equals a plus jb and w equals c plus jd, we see that both numbers are in rectangular forms, and so we proceed to applying the addition operation to real parts and to imaginary parts. The total real part of z plus w will be a plus c, and the total imaginary part of z plus w will be b plus d. Same applies if we do z minus w. Sometimes the case might not be as simple. If any of the added or subtracted numbers is not in rectangular form, then transformation to rectangular form is required before proceeding. For example, assume we want to add z equals r1 at the phase of theta 1 and w equals r2 at the phase of theta 2. Both of these numbers are in polar form, and therefore they must be transformed to rectangular form before proceeding. So the number z becomes r1 cosine theta 1 plus jr1 sine theta 1, and w becomes r2 cosine theta 2 plus jr2 sine theta 2. And now we can complete the addition as summation of real parts plus j times summation of imaginary parts. Let's illustrate this with a numerical example. In this example, we need to determine 5 at the phase of 60 degrees minus 8 at the phase of minus 100 degrees and represent the outcome in polar form r at the phase of theta. To apply the subtraction operation, both numbers must be first transformed to rectangular forms. We actually learned this in previous video. 5 at the phase of 60 degrees is transformed to this, and 8 at the phase of minus 100 degrees is transformed to this, and the subtraction operation remains. All terms would then be evaluated as seen. And now we can do the subtraction. Subtracting real from real gives us 3.89, and subtracting imaginary from imaginary gives us 12.21. And now we have the result as a single number, 3.89 plus j 12.21. The last step is transforming this result back to polar form as required by the example. We learned how to do this in a previous video, and this is our final answer in polar. It is your turn now. These 4 practice problems should test your accumulated understanding of complex numbers so far. Try them out and post your solutions in the comment section. Thank you for watching.